diagram we saw, class order subsystem we have discussed. Now various runtime areas, 5 runtime areas are there. Their information you will get here in this word file. 5 various runtime areas. Yeah. So according to that image, what is the first area? Method area. Second, heap. Third, stack. Out of these 5, we have already discussed heap and stack. You know, when you create any reference gets stored on stack, local members on stack, and heap may, what happens? Objects. We have to just check method area, PC register. PC register, although you cannot understand now, you will understand in multi-threading topic, and native method stack we can discuss. Okay, so method area. Method area stores what? Look at that. Class bytecode. Class loader who loads the class information reference to the class. Class. Static variables. See, static variables. So where are static variables stored? In the method area. Huh? Somebody asked a question that time when I explained static variables. Static members are stored inside method area. Various literals. Literals means constants. Type information. For each type it loads, Java virtual machine must store following kind of information in the method area. Type information. The fully qualified name of the type. Type means either class or interface. Here pe we know only class, so let us talk about class. Fully qualified name of the class. Fully qualified name of the type's direct superclass. Now we haven't started with inheritance. So superclass and all those things we will discuss afterwards. Whether or not type is class or an interface. So whatever you have defined, that is class or interface. That information. The type's modifier, whether that class is public or private or protected or what, abstract, final, etc. Direct super interfaces. Method information. Method information. Method's name, method's return type, number and types of the method parameters, method's modifiers, etc. Method tables. Method tables means method table which will store the addresses of methods. So addresses of methods are also stored in the method area. So all these things are stored in method area. Then heap. Heap is all objects. All objects, all arrays are stored in heap. Stack, we already know. Reference, local members, call stack. Call stack. What is call stack? I just explained you. Even though you know that. What is call stack? Suppose I have got display 2, then I have got display 1. From display 1, if I call display 2, and then I have got main, and from main, suppose if I call display 1. So main calls display 1 calls display 2, and who calls main? JVM calls main. Now here we can see one call stack. What is that call stack? First you have main called by JVM. Then you have display 1 called by main. And then you have display 2 called by display 1. This is called as, this particular thing is called as call stack. So this call stack is also mentioned in that stack memory area. Okay. PC register, PC, program counter register. Every thread has got a different PC register, which stores pointer to the next line to be executed by JVM. So this point you will understand once we discuss multi-threading. At present, you understand that for every thread, different PC register is there. So every thread has got a different PC register, which stores pointer to the next line to be executed by JVM. Suppose thread 1 is going to start at 5th line and thread 2 is going to start at 20th line. So thread 1's PC register will store 5, number 5, from where execution can be started. Thread 2's PC register will store 20. That is from 20, line number 20, execution for thread 2 can be started. So program counter register, every thread has got a different PC register which stores pointer to the next line to be executed by JVM. And then we have native method stack. What is the difference between Java stack and native method stack? Java stack means Java calls Java. Java method calls Java method, another Java method. That is Java stack. But native method stack means Java method, when Java method calls C++ method, that is native method stack. So that information you will get in native method stack. So native method stack comes into picture only when Java calls C++ method. Yeah. So method area stores what? Information about class, whether it is a class or interface. Information about superclass, parent class of that class. Information about modifiers of the class, whether that class is public, whether that class is abstract, whether that class is final, whether that class is static, etc. Static members, methods are stored in method area. Heap, all objects. Stack, reference variables, local members, call stack. PC registers, it stores information about each and every thread, from which line that thread can start its execution. So for every different thread, different PC registers are there, program counter registers. The idea you will get when we discuss multi-threading. Native method stack comes into picture only and only when your Java calls C++ method. So native method stack will hold the information about that native method, the method which is written in the C++. Its call stack will be present in the native method stack. So these are 5 runtime areas of JVM: method area, heap, Java stack, PC registers, and native method stack. And finally, execution engine. Okay. Now, before we discuss execution engine, let me describe execution engine's main role. What is the main role played by execution engine? So we'll go to Canvas. We have a platform. We have a platform, say Windows. We have another platform, let's say Linux. Now every platform has got something called as native code, or local instruction set, LIS, local instruction set. Every platform has got native code or local instruction set. or local instruction set, LI. Now, what is native code or what is local instruction set? Native code or local instruction set on that particular platform, Windows or Linux, is used to execute any program. So you take any platform, Windows, Linux, Mac, Motif, etc. Every platform you will have native code or local instruction set. Why we need native code or local instructions set on that platform? To execute any program. Okay. Now you have bytecode dot class file. You know, Java is platform independent. Compile once and run anywhere, provided JRE has to be there, JVM has to be there on that platform. So this is bytecode, Java bytecode. Okay. Now try to understand one very important thing here. This bytecode you can run on Windows and Linux. This bytecode, which is compiled once, you can run on Windows and Linux. But the main thing here is the format of this bytecode. What format this bytecode is there and the format of native code, they are quite different. Bytecode's format and native code format on a particular platform, they are quite different. They are not compatible at all. Now you need someone in between bytecode and that particular platform. And what that someone will do, that someone will convert bytecode to the respective native code or LIS. So that someone on Windows will convert bytecode to native code or LIS of Windows. That someone on Linux platform will convert bytecode to native code or LIS of Linux. And who is that someone? Obviously that is JVM. Yeah. But in particular, inside JVM, which component will take care of it? Class loader subsystem? No. Runtime areas? No. It's execution engine. It's execution engine. So execution engine का role ये है. Execution engine. I'm writing it short because it's not that easy to write with mouse. Execution engine. Yeah. So what execution engine does? It takes the bytecode and it converts into native code of that particular platform. It takes the bytecode and converts into that particular native code and execute. So that's why it is called as execution engine. So execution engine is the one which converts that bytecode to the respective native code or LIS. So in that JVM architecture, the last one is execution engine. We have a separate file for that execution engine. And that is 6th execution engine. Yeah, 6th execution engine sequence mein. Yes. Now execution engine has got internal components, sub-components. What are they? Interpreter. Interpreter. JIT compiler, just-in-time compiler, hotspot profiler, and GC, garbage collector. Now we have files for interpreter, JIT compiler, GC. GC already know, garbage collection you know. So garbage collector is there inside execution engine. Interpreter and JIT compiler. Now interpreter or compiler, whether interpreter or compiler, their main job is to convert something.
High level to assembly.
Yeah. So here,
high level to
what is interpreter and JIT compiler? Here, interpreter and JIT compiler both are used to convert bytecode to native code. Here, interpreter and JIT compiler both are used to convert bytecode to native code. What is the difference? The difference here is interpreter will interpret one instruction of bytecode into native code and execute. Interpreter will interpret one individual instruction of bytecode into native code and execute. Whereas JIT compiler will take block inside that bytecode and convert that block into native code. So ideally, JIT compiler is faster than interpreter. In the very beginning, JVM had just interpreter, no JIT compiler. So at that time, the speed was so slow, execution speed was so slow. Then they said, oh, we have to do something to make it faster. So then they introduced JIT compiler. So interprets individual lines of bytecode into native code and execute, whereas compiler will take block inside bytecode and convert it into native code. But now there are pros and cons. Pros and cons. Interpreter is slow, obviously, because it takes individual instruction of bytecode and then convert them to native code. Slow. But interpreter does not require any space because interpreter does not save any converted code. It just converts and executes. Whereas JIT compiler, as I said, JIT compiler will take block inside bytecode and then convert it into native code, and then it will save it somewhere. It will save inside cache memory. So JIT compiler needs cache memory in order to store converted code. In order to store converted code. But the advantage of JIT compiler is once it converts that native code, next time if the same code is executed, the same code will be executed, no conversion is required. Like some block is converted already into native code and that block is executed again and again. So now you don't want to again convert that block into native code. You have already native code saved somewhere where in the cache memory. So same code will be executed. So conversion happens only once. But then memory is required, cache memory is required. That is a drawback. Advantage is faster. Next time when that block gets executed again, so same native code will be executed. So there are pros and cons. That's why what is being done is inside execution engine, both are there. So which code will go to interpreter and which code will go to JIT compiler? The code which you call again and again in the program. Suppose you call some method again and again in the program. So that code goes to JIT compiler. So what happens? That code is converted to native code once, and when you call it again in your Java program, just native code will be executed. Just that native code will be executed. And interpreter, which code goes? The code which you don't call again and again, that code goes to interpreter. Because interpreter has got advantage that it does not require cache memory to store the converted code. Moreover, JIT compiler, as I said, it is faster. But for the first time, it is going to convert your block into that native code. So for converting that block, it takes time. At least in the beginning, it takes time. Once it converts, obviously, it will be faster. But for the first time, it takes time. So for the first time, it takes time. To store that converted code, it requires cache memory. These are the drawbacks. Advantage, when you call that code again and again, it is faster. Just that native code will be executed. Interpreter's advantage, it does not require any memory. But drawback, it is slow. one by one instruction will be converted to native code and will be executed. Now who will check within a code a particular block is executed again and again and particular block is not executed again and again? Who will check that? That thing is checked by hotspot profiler. So hotspot profiler is a software or it's a program which checks which code is called again and again. That code will be given to JIT compiler, and which code is not called again and again, that code will be given to interpreter. That job is done by hotspot profiler. And what GC garbage collector will do, it keeps a track of which objects inside heap are in use. In use means they are referred by some reference, and which are not in use. Not in use means they don't have any reference on the stack. So those objects which don't have any reference on the stack, they will be marked for garbage collection. That is the job of garbage collection. So this is all about execution engine. Whatever I said, there are files. Yeah.
So there is one question. Sir, Java C compiler which we used in CMD and JIT compiler, they are same or different?
Different. In fact, that is a interview question. What is the difference between Java C compiler and JIT compiler? So answer is Java C compiler converts source code into the byte code, whereas JIT compiler converts byte code into the native code. Correct? Clear? Clear now?
Yes, sir.
Native codes are the C and C++, sir.
Native code is limited to platform.
Hello, sir. Is Java
every platform has got native code. Yeah.
Is Java compiled or interpreted language?
What?
Is Java compiled or interpreted language?
See, that answer we can give like that. When you write a source code, basically, obviously you are going to use compiler, Java C. Okay. And when you try to execute, your some code is going to go to interpreter and some code is going to go to JIT compiler. So it's both.
Okay, sir. Thank you.
Sir, can we...
Both interpreter and JIT compiler are... Yeah.
Sir, in platform independent language, there must be no JIT compiler.
In platform independent language, there has to be some compiler or interpreter which will convert your bytecode to native code.
And in platform dependent languages, there must be no JIT compiler, so they must be fast like...
No. Correct?
Sir, lag.
So there's no question of
sir, there is
a lag.
audio lag. Could you please repeat it? So,
what?
there is a little audio lag. So please repeat that part again.
Which part?
Sir,
Answer
right
the
now,
question.
answer the question.
Answer the question. Which question? JIT. Java C compiler, JIT compiler. Java C compiler converts source code into the byte code, and JIT compiler converts byte code into the native code. Native code.
So can you repeat hotspot profiler one?
Yeah, hotspot profiler keeps a track which code inside your byte code is called again and again. That code is given to JIT compiler, and the code which is not called again and again, that code is given to interpreter. So hotspot, the meaning of hotspot is the code which is called again and again. That is hotspot. That's the meaning of hotspot. Okay. There are separate files for interpreter, JIT compiler in the same folder. So with that, we have finished JVM architecture. Either question can be asked as explain JVM architecture. So you have to explain whole thing, right from class loader subsystem, 5 runtime areas, execution engine, everything. Or question can be asked individually. Explain class loader subsystem, or explain all runtime areas, or explain execution engine. At that time, you have to explain that. So how Java works. Here we have one PPT also. Let's see that. Role played by interpreter or JIT compiler. Yeah, that's a basic thing which I explained in the beginning on the canvas. Windows platform. Native code or local instruction set as per Windows platform. Macintosh, for example, another platform. Native code or local instruction set as per Macintosh platform. We have bytecode. Now the concept is that this bytecode can run on Windows as well as Macintosh, any platform. But for that, what is important? Someone has to convert this bytecode to Windows native code or LIS, Macintosh native code or LIS. And who does that job? JVM. But in particular, execution engine. In particular, interpreter or JIT compiler. So interpreter or JIT compiler takes the bytecode and converts them to native code or local instructions. That is the main role of interpreter and JIT compiler inside execution engine.
Hello, sir. So this must means we can say that JVM contains all of the different platforms native instructions for converting the bytecode.
Wrong.
Means no. I mean what I'm saying that JVM is like converting every bytecode for it's a software platform, so it converts the bytecode to understandable for each operating system.
नहीं अंडरस्टैंड हाँ ओके ठीक है एक बात समझ लो JVM is different for different operating system, right?
Yes. Yeah.
So JVM for Windows knows how to convert bytecode to Windows native code.
Yes.
And JVM of Macintosh knows how to convert bytecode to native code of Macintosh.
Okay, means Windows or Macintosh हर एक के लिए different JVM.
Yes. JVM is different for different platform.
Okay. हाँ.
Yeah. JVM is different for different platform.
Okay. Thank you. Yes.
Okay. After that, now array. How to create array in Java.